you wake up, we don't fall asleep to have digestion. Okay, so Gabriel is going to speak about KCS 11. And just to let you know, after the last talk tonight, there will be a little closure discussion. So prepare your feedback if you want to see things for next year. It will be the time to say, oh, we want this. And okay, and also there will be a debriefing, I guess, on the war game. So, thank you.
Well, first of all, I'd like to thank the organization for setting up all this event. So, give an applause for them, please. Well, as you can see from my accent, my face and my name is from Spain. So, the title of the talk is Manual Remote, and the subtitle I have changed quite a few times. In the official name, I think it was PKCS 11 for fun and non-profit, but in the end, the POC I want to show is the model using the Spanish national ID, which is something we use in Spain very much, and it is based on P11, so it's something practical and right, that is out there working currently. So the contents of the talk. First, I will try to introduce the DNI. The name is in Spain like Documentación Nacional de Identidad Electrónica, National Electronic Document. So I'm going to call it DNA. Afterwards, I want to explain what is DD to the POC and what I developed for this talk. And we will try some live demo. I will try to access some of my information stored by the government, so some social security information, so if everything works okay, we'll see it. I will also discuss a little of improvements that I've done to the POC I'm going to present here. And I'm going to propose a solution that should be implemented in this kind of smart cards to prevent this kind of attacks. Well, in brief introduction to the DNA, the government, like maybe 5 or even 8 years back, tried to promote the online transactions between the citizens. So they came up with an idea of setting up this electronic ID. So every citizen could do any administrative task online, just from their homes, and without going to go to the physical places to do all the stuff. And they also encourage all the big companies to allow people to use the DNA, sorry, the DNI to access your bank accounts or even bills from energetic companies or whatever information you can do physically in an office. You could do it online to reduce queues and stuff, right? The way it has been implemented is pretty huge fail, and in terms of user friendliness, as I will show you later, they focus so much in security in the deployment of this smart card that one of the profiles they implemented didn't allow caching the PIN number. So in the way it's implemented in Microsoft Windows, every time you open an internet explorer window, or even if you open free tech, every application that uses Explorer extension is going to be required to enter the PIN. So maybe if you're black, you have your DNA black. While you're working, you can entering the PIN like 5 times just for nothing, because okay, you enter the PIN right, but it's going to be asked again. So from the user point of view, it's a pretty fail. So and the DNA is something like that. Here's mine, all right. We have this yellow thing, gold thing, are the contacts for the microchip. And well, it's the information from. Well, introducing what is the smart card implemented in the DNI, because it has 2 microprocessors in it. It has a general purpose microprocessor, which for using APUs. The commands are running the operating system, and that kind of stuff. We also have the crypto chip, which is used to perform the signatures using the RSA keys and that kind of things. And when it uses serial port communication, it could be used USB something, but they decided to use serial port. What has the DNI inside? When you create your DNI and you go to the police to get yours, you have to use your fingerprint. You have to store your fingerprint on it. So every time you're required to generate a new one because you have just missing or it's broken, you're gonna need to require you to use your fingerprint. And the match of the features of the fingerprint is done inside the DNI. I mean, your picture never goes away. It also holds the authentication certificates, which are just to authenticate users against web services. And non-reputation certificate is pretty important because using this kind of marker, specifically this one, you sign a PDF or anything, a transaction, you're going to have legal validation. I mean, you can, if you sign something, you can go to a judge and say, I didn't sign it because it's your certificate, it's not embracer one, so you're going to require to pay whatever it is. And it also holds component certificates that I will explain later is for creating a secure channel between the chip and the PC. Well, how this is being deployed? PCCS is a standard between several vendors that encourage the standard to communicate PCs with the partners. It's multi-platform. It provides an API for communication. And well, it performs this kind of functionality, implementation of the smart card, with management, you can have several of them. And you take the card and you can send, through this API, you can send and receive the PDUs, these are the names of the commands sent to the smart card. And well, the secure channel is a security feature based on this standard, right? And which allows you to encrypt the PDUs. All the commands are going to be encrypted. This is used to prevent man-in-the-middle attacks, right? So if you have a reader that is backed by some vendor, when you buy it from eBay and it's backed by some bad guy, it's important that you wouldn't be able to read your information, your PIN or whatever, because everything is encrypted. This works in the same way as SSL. They exchange public keys and authenticate each other, and then create the decision key for encrypting the whole channel. The way this has been deployed, when you acquire your DNI, you have to store some software in your PC or in your Linux or whatever computer you're using. For Windows, they have this CSP implementation. It's Microsoft proposal, and it's an extension to the crypto API. So every time you're going to perform a signature or whatever, the specific CSP for the DNI is going to be called, and everything is going to work okay. And this is the deployment of typical scenario. There is also another technology used to communicate with the smart card, that is PCCS11. And this standard was proposed by RSA, and in this web page, you have triggers for getting your own libraries. I mean, all the methods are already defined there. And when providing the API for accessing crypto devices, in the abstract, the whole thing based on a token unit where you can perform operations. And lets you manage several objects like public and private keys and data and certificates. And this is the same way as CSP. When the application wants to use a DNI, they are going to interface with the P11. So you're going to use APDUs to communicate with the reader. The APDUs for the DNIR at the beginning were not available. They were only closed source library you had to install, provided by the National Police. So you wouldn't end up sending commands to the smart card. You need to use this library, the official library. Well, as I said at the beginning, the DNI is used to authenticate user against web services. So there are two methods to achieve. One is using an applet, which is kind of an inclusive method, and another one is SSL with the client certificate that is called in the DNI. The Java applet is considered more inclusive method because the user has to download the applet, has to execute it. It's going to see security warning because every time you execute something from Java, it's going to pop up some security warning like this. Alright? And this is currently produced by a bank. If you try to use the DNI, some insecurity is going to appear, and this is not really a problem because, as everyone knows, when a user sees this, they are really seeing things. So they just end up clicking on yes or no, and they don't really care about the information they are seeing. This is the way. I'm going to explain a little bit the way the SSL method of authentication works. It's like, I mean, it's a normal SSL. It's not meant to be really close to the specification, but it's just to give a general idea how it works. The OCSP is a service provided by the National Police, right? Where web servers can ask if the certificates are being cancelled or they did something wrong with that certificate. So the normal station of the cell, finish the station, the server asks for the client certificate, the web browser starts using the CSP or the T11 to validate and get the client certificate. Once you get it, you sign the messages, send them back to the server, and then the server validates the signature against the OCSP, and if everything is fine, you can get into the service. Alright? The DNI, as most of the smart cards we use today, implements lots of physical security countermeasures. And they have power and threshold detection, partition lies to prevent that you use access to remove layers of the chip, flow frequency changes, and all of these features gave the DNI the EEL4 plus, which is a common criteria level for, it said that it implements lots of security features that would prevent attackers to steal the keys for the smart card. Well, explain a little bit of the POC I'm going to show. I'm going to show, I mean, the motivations that led me to write this, a little bit definition of what it is I'm going to personally show, and then a description of the attack, and afterwards the well, why are these companies or even governments deploying this kind of physical devices? Most of them is for increasing the security, because the weak link in security nowadays is the user, the PC of the user. I mean, every dot, the previous dot, you can buy roles so that they are an organized crime against installing Trojans and stealing credentials, all that kind of stuff. So it's supposed that if you use an external device for authenticating users, you are no longer using the user and password method that can be used easily stored by any Trojan. So you end up using an external device that even if someone steals your PIN, your identification number, it's going to be useless because you're going to need to have this smart card plugged into the PC to authenticate against web services. There are two ways of attacking this kind of authentication. One is